Okay, first of all, thanks for joining the webinar and for your interest in our solutions. I'm going to introduce myself. As you can see there, I'm Javier Beruete, Asia Pacific Sales Manager from Kunak, and I will be hosting today's webinar, okay, Odour control in landfills and wastewater plants. I will try my best, okay, to make this webinar dynamic, easy to understand, and of course, my main goal will be to make it useful for you. So I assume that some of you may know Kunak, but just in case someone didn't know it, we are a Spanish company, okay, that we manufacture sensor-based air quality stations for ambient air monitoring and other applications. As I will explain later, our value proposition is the accuracy of our data, so I will try to explain that in the next slides. So after this quick introduction, I think we are ready to start. So we are going to see the index of the presentation. We are going to start checking the importance of odor control. Okay, why should we monitor these odor episodes? We will follow with an analysis of processes in wastewater treatment plants. What are the main processes? What are the gases and the odors generated there? We will continue with the same topic, but for landfills. Okay, the analysis of the different processes in landfills. We will see what are the available solutions in the market, what are the methods we can use to monitor these odor episodes, sensorial and instrumental methods. We will see what can we offer, okay, from Kunak, our solutions, our hardware, software, our cartridge system. We will end this presentation with some case studies, okay, for wastewater treatment plants and landfills. And of course, at the end, you will have some time to ask any question that you may have. Okay, so let's start. Importance of odor control. It's likely that you have asked yourself, okay, why should we monitor these odors? Okay, here in this slide, we are going to analyze two of the main reasons. Okay, we have environmental and social impact and regulation and standards. We know that odor have an impact on health and quality of life, generating different problems such as respiratory irritation, physical symptoms, psychological stress. Also, we know that odors may lead to community reactions and social conflicts, okay, generating some complaints and protests or tensions between communities and operators. Other important reasons, regulations and standards, okay? I will speak more about that later, but no global regulation exists, okay, to monitor odors, and it depends as well on the country and on the sector. Okay, let's go for the processes in a wastewater treatment plant. We know that there are different steps in a wastewater treatment plant, and in this slide, we are going to cover these steps and what are the odors and pollutants generated during the different treatments. Before starting, I would like to clarify that here, we want to show what we have learned from our experience, okay, from our customers and cases that we have in wastewater treatment plants. We know that depending on the country, depending on the facility, these processes might change. Okay, but here we are going to try to show our experience. As we know, wastewater treatment plants involves multiple processes that treat wastewater, removing contaminants and preparing it for discharge or reuse. Along these processes, gases are produced, okay, mainly due to biological and chemical reactions. So in this slide, we are going to try to find what treatments generate these odor episodes. So let's start for the first one, preliminary treatment. Okay, this is the first step. Basically, coarse solids are removed. Okay, no biological activity should occur here, so no gases and no odors are generated. We go for the second step. Okay, sorry. Let's come back. Okay, we go for the second step, primary treatment. Primary treatments or sedimentation process. Okay, so in this step, sedimentation tanks are used. Okay, so we remove solids and certain organic materials. Involves mainly physical mechanisms. Okay, however, some biological activity can occur there. So we can see some odors and pollutants. Okay, for odors, we have here on the left H2S. Okay, and on the right, we have methane and CO2. Okay, we go for the third step, secondary treatment, or also called biological treatment. This is a critical phase, okay, in the wastewater treatment plant processes. The main goal is to reduce this organic matter and solids, to reduce them as much as possible. Usually, above 85% of this organic matter is removed in this step. This treatment could follow different methods, okay, from aerobic processes or anaerobic processes. For aerobic process, we know that this is the process that has oxygen there, okay, so it generates CO2 and N2O, okay. For the anaerobic one, this is the process where we don't find oxygen there. It generates for odors H2S and for non-odors methane and CO2. We jump to the fourth step, okay, tertiary treatment. This one, pathogens are eliminated with chlorine, ozone, or ultraviolet. So depending what is used to remove these pathogens, we can find different gases, okay? If we use chlorine, we will find some chloride concentrations that produce odor, okay? If, on the other hand, if we use ozone, we will find ozone concentrations there. Lastly, we go for the last step, okay, the fifth step, sludge treatment and disposal. It's a critical component on wastewater treatment plant. It's mainly focused on reducing the volume and treating the organic matter of sludge, basically to facilitate safe disposal or potential reuse. This process may have different steps, okay, so I'm going to just try to name them. We can see a tickering and dewatering, composting, and incineration. Okay, depending on the process, we generate different pollutants. Okay, we can see here them distinguish between odor on the left and non-odor on the right. Okay, for odors, we find H2S, ammonia, CO2, SO2, sorry, and for non-odor, we find methane, CO2, and NO2. Okay, so as we may have seen, depending on the process, different pollutants are generated. Okay, for odor, the main ones, and from our experience, the ones we will recommend you to monitor H2S and ammonia. For non-odor, okay, we find methane and CO2. Okay, so now we will take a look at landfill processes. Okay, landfills are significant source of other gases and other pollutants due to waste decomposition. Okay, in this slide we can see that there are three degradation processes that generate these other episodes. We are going to classify them between biological processes, chemical processes, and physical processes. Okay, we are going to start speaking with the biological one. Okay, biological process involves the decomposition of organic waste by microorganisms. Okay, this decomposition can occur in aerobic conditions, okay, with oxygen, or anaerobic conditions with no oxygen. It follows, I mean, it's quite similar to what I've explained in the previous slide with wastewater treatment plants. If we speak about aerobic conditions, aerobic decomposition, we find volatile organic compounds, okay, for odors, and CO2 for non-odor gases. Okay, for the anaerobic decomposition, we find H2S, ammonia, box for odors, and for non-odors, we find methane and CO2. Now we go for the chemical processes. Okay, chemical processes arise from reactions between waste materials and environmental factors like water, oxygen, or microorganisms. In this step, we find other gases, okay? We find H2S and VOC. It's important to mention that we find methyl mercaptans, okay, in this process, that as you may know, it's a pollutant that generates odor, and it's quite interesting to monitor, okay? We will see in next slides, but our H2S reacts to methyl mercaptans. Finally, we have the physical process in landfills. This physical process affects to waste compression, leachate generation, and gas release. Okay. Although modern landfills are designed to minimize environmental impact of these physical processes, it's still playing an important role in air pollution, so we have to really consider that. Okay, so what are the available solutions we have in the market? What are these methods that we can use to monitor odors? Okay, I'm going to classify them between sensorial methods and instrumental ones. Okay, in this slide, we are going to cover the sensorial ones. We know that there are more sensorial processes and methods, but we are going to cover here the most important ones, okay? So we have dynamic olfactometry, okay, that is traditional method, okay? You need people to smell and analyze these samples in a laboratory, and we have field olfactometry that is quite similar, okay? We go for dynamic olfactometry. It has some advantages and some disadvantages, okay? Advantages, it's regulated. It's important to point out that it's regulated only for some countries in Europe. This is not a global regulation. It quantifies odor concentration, okay, as it provides a numerical value for this odor. On the other hand, we find human variability, okay, so we have to use people for this process. So people have differences in odor perception, so this might lead to a higher error, okay. No specific compound identified, okay. People are not able to say what is the pollutant generating this odor. It's quite time and money consuming, okay. You need to go on field, take the sample, bring the sample to the lab, and you require help from people and analyze and smell this sample, okay. So it's quite time and money consuming. For field olfactometry, it's quite similar to dynamic. It has a few differences. It's regulated as well in some countries, okay. It provides real-time results, okay, provides instant odor concentration on site without needing to send samples to a laboratory. It's non-continuous, okay. We have as well human variability, and it's expensive and complex. Okay, so now we go for the instrumental methods. Okay, here we find three different groups. We are going to start with the referent equivalent instruments. Okay, these are typical analyzers that you can find for H2S or ammonia, for example. They provide high data quality. Okay, they are quite accurate. They are regulated and certified. It's important to mention that this regulation is for air quality. Okay, it's not for odor. Okay. They have some disadvantages, okay? You can monitor, as you know, with one analyzer, only one pollutant per analyzer, okay? It's quite expensive to purchase these analyzers and also to maintain them, okay? So knowing these limitations about cost and the limitations of the size of the station, our customers, they are not able to deploy many analyzers in their facilities, okay? So they have a limited spatial resolution. They don't have a huge knowledge of what's happening in their plant. On the right, we have electronic noses, okay? They are portable ones, okay? They are low cost. On the other hand, they have a sensor drift and calibration issues, okay? High uncertainty, okay? And they are vulnerable to contaminants. And on the middle, we have professional sensor-based air quality stations. So it's where we are, where Kunak is. We provide accurate data, okay? So in terms of accuracy, we are 85% as accurate as reference stations. We are going with the certification for air quality. You can monitor several pollutants per instrument. Okay, we will see this in the next slides. It's a cost-effective solution. The purchase price and the maintenance cost is quite reduced compared to analyzers, and it helps our customer to have more knowledge of what's happening in their facilities. Basically, because you can deploy more units doing maybe a fence line monitoring. So air quality stations, what we have, what we can offer, okay, to our customers. Here we have our product portfolio, okay. On the left, we have the Kunak Air Pro, biggest air quality station that we have. It can monitor up to 5 gases at the same time, okay. It has as well particle matter sensor on the top. This particle matter sensor is certified by MCERT for PM2.5 and PM10. It can work with a solar panel. It's fully autonomous. We have as well here some slots, okay, to connect meteor proofs. So it's a quite complete station that will help our customers for practically all the environmental monitoring projects and other projects. Here in the middle, we have the Kunak Air Lite. Okay, it's a more compact solution. Main difference, you can monitor 2 gases at the same time instead of 5 in the case of the Kunak Air Pro. It has as well here a particle sensor, okay, for PM1, PM2.5 works pretty well. For PM10, we have a higher error. It can work with solar panel as well, and we have here a slot to connect meteo proofs, okay? Usually anemometer is the one that we connect the most, okay? Kunaker lights, it's quite useful for these other applications. Okay, for example, wastewater treatment plant. From our experience, we have seen that our customers require H2S and ammonia monitoring. So with the Kunaker light, as you have two slots, you can monitor these two gases simultaneously. As I've been mentioning, we have this smart gas cartridge system. Okay, this is patented by Kunak. Okay, it helps a lot our customers because it allows you to combine the pollutants depending the monitoring project. It's quite easy for the maintenance as well. Okay, you go for the station and you remove the old ones, and you plug the new ones. Here we have some evaluations that we have go through. I will explain that later in other slide. So sensor portfolios. Our solution is quite versatile. Okay, so we approach many different sectors. Okay, so here we have gases. Okay, so obviously depending on the sector, depending on the needs of the customer, they will be requiring some gases or others. Okay, in this case, for other applications, the typical gases that are used, we have volatile organic compounds, we have SO2, we have as well H2S. Okay, we have ammonia. So these are the typical ones. And also we are always developing new technologies. Okay, so we have new cartridges coming soon. So air quality software. Okay, so with our hardware, we have software. It's called Kuna Cloud. Okay, so our stations sends real-time data to our software. So it's the place where our customers check the data and do their analysis. Okay, it's a cloud-based platform, real-time analysis, it's flexible and scalable, and it has a complete suite of tools. Okay, so here we can find some of the tools that are quite interesting to help our customers. We have alarms warnings. You can set 3 holes, okay, in case you want to check, for example, H2S, okay, you can put these 3 holes. So whenever the level of H2S exceeds this level, you will be getting an email. We have pollution sources and leak detection tools. You connect anemometer to the station, so you can use these interesting tools to detect other episodes and possible leakages. We have as well AQI index. It's good to know that you can compare the level of the odor or air quality from your stations against the AQI in your country. We have multi-parametric analysis and automatic customized reports. Okay, with the cloud, with a few clicks, you can make automatic reports. Okay, so it's good to see how it's your pollution and how it's everything in your plant. So Kunak today, here we can see some references. Okay, we have been awarded by the US EPA and ERPARIF. We have been awarded by the European Commission. We are working with them to create certification for sensor-based technology. We have global presence. Okay, more than 300 customers. Okay, in more than 80 different countries. Our technology is patented, and we have 8 protected industrial designs. So as I mentioned at the beginning, our value proposition is the accuracy of the data. We consider that if you want to monitor what is in the air, what is happening in the air, it's crucial to do it with an accurate device, okay? Because we want our customers to take right decisions. So we have invested a lot of our time just to present our technology to some evaluations. Here you can see some of them. I want to point out AirLab. Okay, this is a microsensor challenge. Okay, where many different sensor-based manufacturers are tested. Okay, I'm glad to say that in the last 2 editions, okay, 2021 and 2023, we were awarded as the most accurate multi-pollutant sensor against 52 different sensor-based companies. So I think that's a quite good reference. Also MCERT, okay, for the particles of the Kunaker Pro, with the US EPA, okay, EcoSpec. So feel free to reach me, okay? I will be happy to share more information about these evaluations, but I think it helps a lot for you to identify what is this reliable brand that you should trust in. Some real cases, okay, projects around the world. Okay, so this is a project in Middle East where we deploy 10 stations for fence line monitoring. In this case, the customer wanted to identify these other episodes, okay, and improve their processes, okay. Uh, in this case, it was 10 Kunaker Pros, as we can see in this photo on the right, and the Kunaker Pros had anemometer, okay. So thanks to the anemometer, the customer could take advantage of our advanced analysis tools, such as solar polar plots. Okay, we can find here a screen capture, okay, from our cloud of the polar plot tools for A2S detection. Okay, it's quite good because if you just put attention to these red dots, okay, you can see how they mark where this pollution is coming from. Okay, it tells you a little bit about the distance and mainly the other source. Okay. So as we were speaking about A2S, I think it's important to mention this, okay, about our A2S sensor performance. Here we can see a testing that we carry out, okay, with our A2S sensor against a reference station analyzer for A2S. Okay, we can see here that the correlation is pretty well, is pretty okay, 0.77, okay. But we saw that in some places, our A2S sensor was reacting with some peaks and the analyzer was not doing that. Okay, so we wanted to find out, okay, what was happening there. That's why we deploy, okay, also the VOC sensor. Okay, so we saw that whenever our A2S sensor was reacting to these spikes, to these peaks, the VOC sensor was doing that as well. Okay, so we came up to the conclusion that this was due to melting mercaptans. Okay, so our A2S sensor reacts to melting mercaptans that, as I mentioned at the beginning, is quite interesting, okay, because it's a gas that produces odor, okay, so for wastewater treatment plants and landfills is something that I think will make the difference. So, you know, Kunaker Pro sensor for A2S reacts to melting mercaptans. The analyzer for A2S doesn't react to melting mercaptans. Here we have other case study for landfill and biogas plant. This is a quite interesting case study. Our customer was the biogas plant. Okay, he received some complaints from nearby communities due to these other episodes. So he wanted to demonstrate if he was the responsible for those odors or if the landfill nearby was the responsible for it. Okay, so what he did, he deployed, okay, Kunaker Pro Station here, okay, on in the X that you can see on the map, and thanks to the Kuna Cloud tools, okay, thanks to the polar plot, I mean, here you can see the different pollutants that this customer deployed. We find 3 other gases. We find ammonia, H2S, VOC, and we find as well methane. Okay, so with the polar plots, same as we were speaking about, we were speaking previously in the Middle East project. If we check these red dots, okay, thanks to the wind speed and wind direction, we are able to check that the ammonia is coming mainly from the landfill, H2S as well is coming from the landfill. For VOC, it's coming, I would say, landfill and biogas, okay, and methane is coming from the biogas. Okay, so here the customer was able to identify that, yeah, these other gases, okay, ammonia and H2S were coming from the landfill. Okay, so he was able to prove to these nearby communities that he was not responsible for these other episodes. Here we have other case study for landfill. This is a project in Panama, okay? Our customer deployed 3 Kunaker lights, okay, with A2S and methane. Basically, here we can see some of the results. The customer was able to detect all our episodes, okay, have continuous measurements, reduce public health risk, and optimization of their processes. So as I was speaking in the previous slide, in this application for the landfill, the customer deploy H2S and methane. So as we have been seeing during the presentation, methane is not another gas, but is usually presented in these other applications. Okay, so it's important to mention about this methane sensor. Okay, so we have just launched a new methane sensor that I think it's quite awesome in terms of performance and price. Okay. it monitors from very low concentrations, okay, from 2 ppms, okay, with high accuracy. Okay, so it's ideal to detect these leakages and in the different wastewater treatment plants and landfills. Okay, here we were testing, okay, our new methane sensor. So we test our methane sensor against a TD-LAS. Okay, so just in case you don't know, TD-LAS is a typical device that is being used to monitor methane concentrations. It's quite more expensive compared to our sensor. So we can see here, okay, that the correlation of this testing was quite good, 0.95 with a minimum error. Okay, so it's I will say an awesome sensor. Okay, and we are feeling demand from our customers. So if you need additional information, feel free to reach me out. Okay. So global presence, I've already mentioned this, but I think we are a quite well-recognized company in the market. We have global presence, more than 300 customers, okay, presence in more than 80 different countries, and we have an extensive network of partners, okay, that right now I think we have more than 40 different partners in different countries, okay. Here you have some of the companies that are already trusting in Kunak, okay. So I think that's practically all, okay, regarding the presentation, this webinar. So thanks you very much, okay, for your attendance to this webinar, and thanks for our partners. I know that some of you are checking this webinar, so I hope it was useful for you. Now it's time for your questions. Okay, we will have the help from Irene Lara, it's product manager from Kunak. So for these technical questions, she will help us to answer them. Okay, so I think Irene is
Hello,
joining
good morning.
webinar. Thanks, Irene, for joining. So let's try to see the questions. Can we integrate all cartridges in a single sensor? Okay, so as I mentioned in other slides, with the Kunak Pro, it's the biggest station we have. So you can integrate up to 5 cartridges, okay, at the same time, plus particle matter, okay? So yeah, it's possible to integrate the cartridges, and also with the plug and play system, you can combine, okay? So imagine that you want to monitor more than 5 gases, you can combine them, okay, using the plug and play system. Okay, other question here from Mauricio. Which is the measurements principle of your smart gas cartridges? Electrochemical sense. Yeah, you are right. Practically, the majority of our sensors are electrochemicals. Yeah, you are right. We have other technologies as well, but practically, they are electrochemical and they have a 2 years lifespan. Okay, other question from Sidet. Okay, does this sensor have open API? Yeah, you are right. I mean, we can integrate the data from our platform to other platforms using AP REST manual. We will be happy to provide you with this AP REST, and of course, after this webinar, I will send you the AP REST manual. It's quite easy to integrate the data. Okay, using AP REST. So yeah, of course, it's quite commonly demanded by our customers. Okay. Can these sensors do a mapping? Okay, I lost the question. Okay, just 1 second. Can these sensors do a mapping on different pollution sources? Yeah, if I understand your question, we can use our pollution source and liquid and polar plots. Okay, we can use hotspot to identify the source of this pollution and others. Okay, other question from Mikhail. Can your sensor send a signal to another treatment machine so that it starts up as soon as a pollutant threshold is exceeded? I'm not really sure, but I think this is possible. Okay, it's basically you will need an integration. Okay, you will need to program okay our Kuna cloud just to send this signal, okay, to this other treatment machine. Okay, this way it starts to work. I think it's possible. We will need to check it with our support team, but yeah, I think it's possible. I did Luis Martinez. Okay, I did not understood to which captors the H2S sensor was reacting while having the peaks. Can you write it here, please? So yeah, as I was mentioning, I mean, maybe Irene can answer this question better than me.
Yes, I already wrote the answer, but I don't know for for which reason it disappeared, I think. So this H2S sensor is also responsive to mercaptans. So this is the reason why we were showing some peaks when the H2S analyzer was not measuring anything, because the H2S analyzer only detects H2S, but our sensor has also this additional feature, I would say, so it is able to detect also mercaptans, which are responsible of others.
Okay, thanks, Irene. Okay. See the next question. We have here many questions. That's good. Okay, so thanks, Roberto, for your question. Do you have any experience in mine operations? Yeah, we have, I will say, huge experience. Okay, we are working, I will say, with practically the biggest mining companies worldwide, as can be BHP, Glencore, Vale, Barrick. You can find some case studies in our webpage, and of course, we will be happy to provide you with this reference by email. Okay, Ingrid is asking, are you aware of any further regulation to be applied on the EU level? I think Irene knows more about you in terms of Asia Pacific region, so I let you this question, Irene.
Yeah, as far as I know, regarding others at the UE level, I'm not aware of any further regulation that is applied. So yeah, the only thing is that we are part of the working group, the European working group, which is working on trying to set an standard for evaluation of instrumental devices for Odour monitoring, because currently there is no standard to evaluate them. So that's the only thing I can say.
Okay, great. Other question here. Do you have another index since not formal international definition? We will be glad to understand your definition. So Irene, if again you can help us.
Yeah, currently we don't provide any other index. So the only the data we provide is the concentration of the different pollutants. So no other index so far.
Okay, we have other question from Fuad. What is the maximum range of detection? So it depends on the pollutant. I don't know if you want to specify the pollutant, but yeah, we can send you our data sheet. You can find there all our ranges, accuracy, and all the data for the different pollutants. Okay. Do you have solutions for odor management, or it's just monitoring? I think we have already answered this, but yeah, I mean, we have monitoring, okay? So we don't have we cannot provide another index. Okay. Other question, for every sensor, how long their service lifetime, and how do we calibrate the sensor itself to ensure their performance? For the lifespan, usually the electrochemical ones, they last 2 years. Okay, so after 2 years, we have to replace them. And for the calibration, we have different methods. Okay, we have to distinguish between calibration and correction. Okay, correction is the one that we adjust our baseline using the Kuna Cloud calibration tool. Okay, and for the calibration, we have two options. Okay, we have a collocation study against a reference station, or we can use our gas hood. Okay, among all these gases, ammonia, VOC, H2S, methane, which one, do we conclude that there's others in my area? It will depend on your application, Eva. So if you can share with us the application, maybe we can help you more. But yes, you were mentioning for odor, we know ammonia, VOC, and H2S produce odor. When we speak about methane, this is a non-odor gas. Okay, so I assume that methane will not be responsible for these odor episodes. So if you just send us an email with more details of your project, we will be able to help you better. Okay, seated. Okay, other question. We would like to monitor odor in a luxury apartment building with sewage smell. How your sensors can help us for an indoor space? Maybe Irene, I don't know if you can help us better with this one for indoor.
Yeah, so if the problem is coming from outside, because maybe these buildings are close to a sewage plant, you can install Kunak sensors in the fence line, I would say, in outdoors. And then by ensuring that this, by monitoring outdoors, you will ensure that this odor does not come into the building. That could be an option. But for sure, if you want to talk about a specific application, feel free to reach us and provide more details so we can provide you with a more tailored solution.
Thanks, Irene. Other question from M. Cabeza. Does your cloud have the limits of units of odor, or can it notify you? It's the same. Okay, we cannot tell you the unit of odor. Okay, we will tell you the level of concentration for these pollutants responsible for odor. Okay, as can be H2S, ammonia, VOC, but we cannot tell you units of odor. Other question from Ingrid. From my knowledge, the new Air Directive 2024 does not concentrate on odor emissions, and what I could find is a standard emitted by since it's in 2022 regarding the regulations on dynamic olfactometry, but not something specific on limits. So Irene was speaking a little bit about the status for these certifications. I don't know if you want to mention something.
Yeah, so this standard that you mentioned is to perform the dynamic olfactometry, but as you mentioned, there are not specific limits. I know that in some countries there are limits for H2S. I think around 30 or 40 ppb, but it's something like country specific. So that's the only regulation I know regarding.
Thanks, Irene. So now, Eva, other question, can we do field calibrations or must we send back the sensors for calibration? Okay, you don't have to send the sensors back for calibration, okay? So we can do field calibrations, okay? As I was speaking before, we have correction and calibration. So calibrations are the ones done on field, okay? So yeah, we can use the gas hood, okay, to insert gas in the sensors just to see how they respond and calibrate them, or we can do this field collocation against a reference station to calibrate our sensors. Okay, so yeah, I mean, for the replacement, you don't have to send the device either, okay, to our facilities. We will ship to you the new cartridges, okay, so it's that easy as you will receive the cartridges, go to the station, put it in sleep mode, remove the old cartridges and plug the new ones, okay? So the station, once you turn it on again, will recognize these new sensors, okay? So it will be ready to start monitoring in 5 minutes, okay? You will be able to do this replacement. Okay, other question from GC Sterk. Have you done any studies comparing the measurements through traditional odor measurements, technical or odor intensity surveys? Maybe Irene knows more. I mean, we have done testings, okay, against analyzers, okay, for air quality instruments, but I'm not really sure compared to other measurements techniques, as can be sensorial ones.
Yeah, so as Javier mentioned, we have compared our devices with analyzers, but not yet with olfactometric measurements.
Okay, one other question, how do the sensor work? Is it this diffusive passive monitoring or there are any air pump? Okay, so if passive, we don't have any pump in our station. So basically our station is designed to let the air flow, okay, and react to the sensors. Okay, so this is the way we work. Okay, and other question from Roberto. Regarding to Eva question, where we can find the calibration gases, okay? I don't know if you are speaking about the gas hood, okay, but we can send you the gas hood manual, okay? So it's like a guide, okay, to help you how to use this gas hood. I don't know if you are referring to the gas hood. No, the gas bottles. Okay, so for the gas bottles, yeah, in the gas hood appears as well some recommendations for the different gas bottles that we should use. Okay, so we will be able to send you an email, Roberto, okay, with more information about the gas bottles that we should use for calibrating the different sensors. Do you have any instruments for corrosion monitoring for oil and gas companies? I'm not sure. I think we don't have any correction. Maybe Irene knows a little bit more about correction topic.
No, we don't have an instrument specific for corrosion. If you can specify if you are looking for a specific compound, maybe we can provide more information.
Okay, so many thanks for your questions. We have had many questions, so that's good. Okay, it seems that you like the webinar. Other one. So okay, H2S, CO2, and other gases. So this is what the question related to correction, to the corrosion. Sorry. So yeah,
Yeah,
Irene.
so for example, yeah, as it has been shown in this webinar, H2S is one of the sensors we have, and also SO2 we are able to monitor, and also HCl as well, that I believe it can produce corrosion. So this type of gases we are able to monitor. If feel free to reach us and we can provide with the catalog so you can see the different rates of sensor we can offer.
Great. So I think we don't have more questions. So I really appreciate your attendance to this webinar and your time and your questions, of course. I would like to thanks as well, Irene, okay, for helping us with these technical questions. So we will do a follow-up, okay? We will send you the record of this webinar, and of course, feel free to reach us, okay, by email. You can find there my email, okay, my phone number. So I will be happy to help you with all your doubts. Okay, thanks for your time and have a good day. Okay.
Thank you. Goodbye.